Assalamualaikum warahmatullahi wabarakatuh. Greetings to KD Pusbuana and SKI Lab Assistant. We're from Group 7, and today we're going to present our Industrial Statistics Practicum report about analyzing time needed for marbles and golf ball to reach the bottom of container on liquid. As for the members, we have myself, Alya Khanaya, Athifa Lalitya, Irene Salsabila, and Sri Maharani. Here are our tables of content. Next, please. Okay, so first and foremost, we're going to show you the background as to why we chose this topic with SEQ method. Now, engineers frequently create devices that carry out liquids. Therefore, engineers must also grasp how fluid behave, especially considering it from its viscosity level. If the measurement of the viscosity level is not right, it can cause serious problem to a firm. And that is why the experiment must be made to ensure that all of the liquids used are suitable for the design devices or product. Now, from the complication, we can narrow it down into one key question, which is how can we implement the DOE by aligning an idea based on the liquid's viscosity? Now, this experiment was carried out with the purpose listed here, which is to determine if solid ball size, height of dismount, and fluid's viscosity have significant impact to the time taken for the solid ball to reach the bottom of the container. Based on the ideation of the experiment, we must first gather basic understanding of viscosity. Well, viscosity itself is a property of a fluid that is caused by the presence of substance between the liquid's molecules and the liquid's cohesive force. For example, if we drop a little ball into a liquid, we can watch how the ball sinks quickly at first and then slowly until it reaches the bottom of the liquid. Next, please. Okay, now from the example before, we can have an understanding that the ball's velocity changes because of the viscosity of the liquid. That could happen due to the factors that will exist during the experiment, such as the density of the ball, the coefficient, and many more that are based on the formulation written to the right. Next, please. Okay, so in conducting the experiment, it is also crucial to acknowledge the definition of DOE, or design of experiment, which is the field of study that we're going to use in this practicum. Now, since DOE can be applied to various of experiment, in this case, we're trying to obtain the effect between the viscosity of the liquid and ball density towards the time estimation. Next. After knowing DOE, ANOVA must also needs to be implemented. There are two types of ANOVA, one-way ANOVA and two-way ANOVA. And for this case, we're going to use the two-way ANOVA. Next. Here are the purposes of conducting the experiment. We have the application. The next one is for the relationship between factors included. And the last one, we have a factorial design method for solving DOE.
Moving on to research methodology, for the problem identification, we will analyze the time taken by balls that is influenced by the type of liquid and the dismount height. For the variables, we divided it into two, which are response variable and control variable, where in this case, response variable is the time taken by balls to reach the bottom of liquid container, while control variable is anything that is constant. In this research, it consists of container size, liquid height, temperature, and atmospheric pressure. For the DOE method, we will use factorial design, where in this research, there are three factors in total. The details of the factors and levels are shown here, where there are three factors. First is balls that has two levels, liquid has two levels, and also this liquid has three levels, and also dismount height has two levels. For the data collecting, we're using Minitab to generate the outline of the factorial design. And then after converting the data from Excel to Minitab, we click on Stat and choose factorial in DOE option, and then choose the general full factorial design. And then after the factorial design is already inserted by the factors, and we already determined the number of levels under application, we randomize the standard order and run order. And then we move to the data processing. In the data processing stage, we're checking and interpreting the assumptions in DOE. And to prove those assumptions, we need to conduct two essential steps, which are model adequacy and interpreting main effect, interaction, Pareto chart, and p-value.
Based on the experiment that has been conducted beforehand, we obtained the data which illustrates the velocity of ball falling in a varying liquid type on a certain height. We carried out the experiment by undergoing three replications. As you can see here, on the second bottom row of the table, we symbolized marble by D and dismount height by C. Next. The observational data here displays the standard order, which is the original sequence of the experiment for multifactor. Then we randomize the data, which will then guide us on what order should we perform the experiment in. Upon performing this experiment, there are three factors that are involved in this experiment. First, liquid type, which has three levels, consists of tap water, cooking oil, dish soap. Second, which is ball type, which has two levels, which consists of marble and golf ball with a diameter of 1.4 centimeter and 4 centimeter respectively. And lastly, this mount height, which has two levels, which is classified into one, 0 centimeter from the surface of the container, and second, 10 centimeter from the surface of the container. Next.
For the data analysis, first we perform homogeneity test, and from the graph of versus fits, it can be seen that the data are not scattered around, and we can predict that the data are not homogeneous. However, Levine test was then conducted to finalize, and a p-value of 0.502 was obtained. Thus, since it is larger than the significance level, we can conclude that the obtained data are actually homogeneous. Next, please. Next, for independence checking, since from the graph it does not show any particular patterns, data obtained are independent. Next, please. Next, normality test was conducted and showed that the data are not normally distributed. Box-Cox transformation was then conducted and data is still not normally distributed. And further transformation will not be performed. Next, please. Then we'll look at the main effect plot, and we can conclude that all of the main effect has impact on the experiments. However, the most significant impact is given by the liquid type. Next.
From this interaction plot graph, we can determine whether or not there are any interactions between the three factors. We then recognize that liquid type and dismount height undergoes some interaction as it has the most evident intersection line. On the other hand, both liquid type and ball type or ball type and dismount height interaction do experience some interaction, albeit not as significant. The order of interaction with the most significant impact are first liquid type and dismount height, second ball type and dismount height, and lastly liquid type and ball type. Next. From the Pareto chart graph on the left side of the slide, we can determine the factors that have the greatest effect on this experiment. This can be seen from the chart that exceed the red dashed line of the value 2.07, with liquid type being the factors that possess the greatest influence to the experiment. The factors then followed by ball type, dismount height interaction between liquid type and dismount height, liquid type and ball type, and lastly liquid type and ball type. Next.
Lastly, p-value from the ANOVA was checked, and it should be noted that if p-value is less than the significance level, the factor or interaction is significant to the experiment, and if p-value is greater than the significance level, the factor or interaction is insignificant to the experiment. And from the result of ANOVA, it can be concluded that the significant factors and interactions include all main factors and all two-way interactions. Meanwhile, insignificant factors and interactions include three-way interactions. Next.
Based on the model summary, we obtained the standard deviation between the data values from the regression line is 0.16696, which means that the average distance of the data points from the fitted line is about 0.17%. Next, the coefficient of determination, which is the squared value of the multiple correlation coefficient, is 95.77%. This indicates that the model has predominantly explained the variation in the response variable around its mean. Third, R-squared adjusted take into account the number of independent variables used for predicting the target variable to find out if new variables would actually increase the model fit. The value we get is 93.88%. The value of 88.69% indicates us the accuracy of the regression model predict for future data. Next slide, please.
To sum up the data that has been collected and analyzed, it can be concluded that first, the ANOVA assumptions from model adequacy checking, we are able to prove that the data is homogeneous and independent. For the normality of variance, the data is not normally distributed since the p-value is less than a significance level. Second one is based on the main effect plot and Pareto chart, the biggest factor that significantly influences the result is liquid type. And last but not least, from the interaction plot, the factors that can be seen to significantly interact with each other are liquid type and dismount height. Here are the references for this research. That's all. Thank you for your attention.